Space optimized dynamic programming for longest common substring. Whatever you're seeing here is what we learned in the last lecture. There we learned about longest common substring problem and the dynamic programming solution that can be used to solve it. We learned that we need a dynamic programming table and we have to fill the complete table in order to find out the right solution. We also showed how to fill the table and find out the length of longest common substring and also what exactly is the longest common substring. This is what we learned. We had seen the space complexity is order of mn and what was the time complexity? Time complexity was also order of mn. In this lecture, we are going to see how can we decrease the space complexity from order of mn to order of minimum of m and n. This is what we are going to see. In order to do this, one thing you have to understand here is, while we were filling this table at any point of time, what is the information that was required in order to fill any particular entry? The only information you needed was information of the entry diagonally above it. This is the only entry you need to fill any particular entry. Whichever be the entry you are filling, you want the entry diagonally above it. All other entries are irrelevant for filling any particular entry. This means while filling any row, the only information that you need is from the row right above it. You don't need any other rows while you are filling any particular row. Because of this, instead of this complete table, you can use a single array and you can store those values which are in the row right above the present row. Using this logic, keeping this in mind, we are going to use an array and convert this whole algorithm such that instead of the table, it makes use of an array. So using this, time complexity will be same, but space complexity will come down. This is the logic. Let us see the algorithm that we already learned and we'll do modifications on this algorithm in order to use an array instead of a two-dimensional matrix. This is what we are going to do. Let us look at the first step. In the first step, what did we do? We had a two-dimensional dynamic programming table which was of the size m plus 1 cross n plus 1, where m is the size of your first string x and n is the size of your second string y. What are we going to do now? Instead of this, we are going to do a simple array. We are going to have only an array. Instead of the two-dimensional matrix, you have a one-dimensional array. We'll call it dp of n plus 1. Instead of an m plus 1 cross n plus 1 matrix, we are going to have an array of the size n plus 1. What about this array? This array, see, it need not be n plus 1. It can be m plus 1 also. This depends on whether m is smaller or n is smaller. Whichever is smaller, accordingly you choose the array. We are considering that n is smaller and you will have another variable called max length which you will be using in order to store whatever is the maximum length recorded till this point. You will also keep track of index. This is what we learned. Along with that, you have to, let me just note here down that x is one string, it is of length m, y is the other string, it is of length n. This is just for reference, okay? What about the next one? We described what is each entry dpij. Now that we don't have this dpij, this is insignificant. The same concept, that is whatever was signified by that entry, the same thing will be signified by each of the entry in this array. But the difference is, in each iteration, we'll update this array. So at each iteration, you should consider that whatever we previously did with one particular row, the same thing we are going to do with one particular array in that iteration. Just that we are not storing all the previous iterations. This is the only difference. What about the next step? Instead of making first row and first column as 0, you can simply define this array as all zeros. That is good enough. So this is also gone. Let us go to the most important step now. You are iterating through each entry and you are entering the values in the matrix according to whether the values in the strings are matching or not, whether the ith character in X is matching with the jth character in Y or not. Depending on that, you are going to update each entry in the matrix. Instead of this, how should you do the updation? The logic is same, but just imagine that instead of matrix, you are using an array, and instead of looking at all the previous rows, you are just looking at the row above it. Okay. In that case, what should be your second step? One thing, you should iterate through all the elements of array. Here, because we are taking an array, let me specifically write that you have to go through all the characters of one string and then through the other string. When it is a matrix, it is evident because anyway you will be going through both strings. So you iterate over each character of X. So this is in your outer loop. In the outer loop, you are iterating over each character in X. What will you do then? One thing, a special modification that you have to be careful of is, you should use a variable called previous. What is this variable for? The requirement of this variable is, while we are updating the elements of this array, you will be altering whatever entries are previously present. But if you want to fill any particular entry, you want the entry which was previously diagonally above it. That is, the entry from the previous iteration. If you are considering arrays, the entry that was present in this place from the previous iteration is required in order to update this iteration. So, in order to cater to this need, what will you do? You will keep track of whatever was the diagonally above element. That is, in matrix terminology, the element diagonally above. In case of array terminology, the element in j-1th position, but from the previous iteration. That is what you should always keep in a variable called previous. How is this managed with just a variable? That we'll see as we do this. Okay. So the previous variable, what will this store? This will store the value of dpj-1 from the previous iteration. Okay. This is the logic. How is this done? We'll see it. You'll understand. The next thing is, you have to iterate through each of the element in Y. So for each element in X, you have to go through all elements of Y. So iterate over each element in Y. So this is your inner loop. Okay. IL denotes inner loop. In the inner loop, what should you do? Logically, the updation is same. But when you write it down, there is a slight difference. The difference is, in case xi-1 equal to yj-1, this will hold because your strings x and string y are the same. What is the updation? Instead of updating this matrix element, instead of dpij, you have just dp of j because it is an array now. So dp of j, how are you going to update it? This is equal to, instead of dpi-1 j-1, that is diagonally above element, what are you going to do? You are going to keep that value in variable called previous. So instead of this, you will have a variable previous. So whatever is the element value in variable previous, that plus 1. This is what you are going to do in case of array. I know you might be thinking that how is this single variable storing the value required for complete array? That we'll see when you actually write the pseudocode. We'll do this right now. Okay. After this, we'll write the pseudocode. So there should be, as of now, just understand that there should be a variable called previous, which will store the value that is in the element just before it, that is dpj-1 from previous iteration. If I write dpj-1 here, what is the problem? The problem is, if I simply write dpj-1, the value of dpj-1 will be updated before updating dp of j in this particular iteration. Because of this updation, dpj-1 will be holding the value of present iteration. But whatever you want is the value of previous iteration, that is before your updation. That is what you will be storing in previous variable. Okay. Next step is dpij equal to 0. Instead of that, you will have dpj equal to 0. Here, because it is simply 0, you don't need any other complications. It is dp of j equal to 0. If xi and ith element of x and jth element of y are not equal. In that case, it is dp of j equal to 0. The remaining things remain the same. You have to keep track of the max value. Whatever is the max value, that is your longest common substring, the length of longest common substring. How do you track back the longest common substring? That also logic remains the same. From whatever index you found the max value, you will backtrack and find it out. Let us see the exact pseudocode. I'll just remove this table because this table is not required anymore. We'll write the pseudocode here. The reason I'm writing pseudocode here is I want you to be clear of how we are using one extra variable called previous, and using that variable, how are we able to manipulate one complete row. This is what I want to discuss here. So in the pseudocode, let us say the function is called LCS. We'll have LCS of x and y. X and y are the two strings. In this case, what should be the steps? First step is to have a DP array. So before you have this DP array, you should know the lengths of x and y. So first of all, let us understand m is equal to length of x, and we'll have n is equal to length of y. So one thing I'll do here is, when in this algorithm, I'll be doing it according to n. That is, I'll consider that n or y is the smaller string. N is the smaller value, y is the smaller string. So for you, if the first string is smaller, just exchange m and n. Or otherwise, you can write the algorithm according to m, whatever, according to your wish. In this case, m and another, what is the next step? You want to have a DP array. So you will have an array DP. What about this? This is of the size n plus 1. It will be having all zeros. So instead of the matrix, we are having an array. Okay. After this, you should have variable. I told you, you should have previous variable. That is one thing. One more thing is, whatever we used in the last lecture, that is whenever we wrote the pseudocode for the complete table, we had one variable to keep track of max length. So one variable will keep track of max length, whatever is the maximum length. This is equal to 0. This max length will be holding the size of longest common substring whenever you complete the algorithm. Okay. What about the index? Let us say index is also equal to 0. These are the two additional variables that you want. What will you do now? You will iterate through each entry in string x and each entry in string y. As we discussed here in the algorithm, what did we write? Iterate over each entry of x in the outer loop and then keep a variable previous, and using that iterate over each entry in y in inner loop. This is what we are going to do. So this is what we are going to implement here. This is what we had from the previous lecture. We'll remove this off. So in the algorithm for LCS, next step is we are going to iterate. So for I is equal to 1 to m. So we are going through each entry or each character of x in this outer loop. Next thing is, I told you we need a variable previous. This will keep track of whatever is the diagonally above element in case of matrix representation, or if you understand here, in array representation, this is the element which is present in j minus 1th position from previous iteration. This is the point. You need it from the previous iteration. This is equal to 0. Next thing, we are going to iterate through the inner loop. For j is equal to 1 to n. This is through the string y. Whatever is your string y, we are iterating through it. While iterating, what should you do? First thing is, you should keep the value of dp of j, that is the present element. Its value should be preserved somewhere. The reason is, this will be the value previous when you reach the next position in the next iteration. Because of that, you should conserve this somewhere. How do you conserve this? For this, so next iteration, in the sense, presently whatever this value is holding, this is the value from previous iteration. Keep that in mind. So because it is the value in previous iteration, you want it in the present iteration for updating next entry. This is the point. You are presently going to update present entry. which is jth entry, but the entry which is present there as of now is the entry from previous iteration. So you want that entry while you are updating j plus 1th position. Because of that, you should keep it somewhere. So how do you keep it? We'll have a variable called temp, temporary variable. In this variable, you will simply store dp of j, whatever is the present element. So j is the present one. What will you do now? Now that you have dp of j stored somewhere, if you want to update, you can update. How will you update? In case the values match, that is when you want to update. If x of I minus 1, if this matches with y of j minus 1, if this happens, then what should you do? You should update value of dp of j. So your dp of j, this will be updated as whatever is the value at dp of j minus 1 from the previous iteration. This is the point. As of now, if you simply write it like this, that is dp of j minus 1 plus 1, what is the problem here? The problem is dp of j minus 1 was already updated in the previous step because you are iterating from 1 to n. dp j minus 1 was already updated in the previous step. So whatever you fetch now will be the updated value, that is the value in the present iteration. But what do you want? You want the value from previous iteration, which is stored in the constant called previous, not constant, variable called previous. So you will take previous plus 1. This is in case it matches. What is one more thing? You have to keep track of maximum length and the index. How do you keep track of it? You will say if this dp of j, which is updated, if this is greater than your maximum length, that means you have to update the length of your LCS. In this case, your new max length, this will be equal to dp of j. You are updating the value of LCS of now. So whenever I say LCS, keep in mind, we are discussing longest common substring here, not about longest common subsequence. For longest common subsequence, we already discussed in that lecture on longest common subsequence. Here we are discussing longest common substring. So this is dp of j and index. Your index is equal to I. Why do you want to keep track of index? Because this is useful in order to identify what exactly is the longest common substring. From here, from this max length, you will only get the length of longest common substring. If you want to know what exactly is the longest common substring, you should also know what is the end index. From this index, you can take maximum length number of characters that are previously existing. Okay, that is how you will find out longest common substring. So after this, what if it is not matching? Here, in case the values are matching, you want to do all these. In case ith element of x and jth element of y are not matching, in else case, what will you do? In else case, you simply have to make it 0. That is dp of j, this will be 0. This is easy. One more thing. One thing that we didn't do here is very important. That is, how did this variable previous get the value here? You have to keep it updated. So in order to keep it updated, what should you do now? Your previous should be equal to temp. Why am I doing here? What am I doing here? Temp is storing dp of j. That is the present element. We stored it in temp before making any modifications. So if we made any modification here, that won't affect temp. So what will temp hold? Temp will hold the value that is present in the present index dp of j, which is existing from the previous iteration. That is what temp is holding. In the present iteration, you updated the value, but temp still holds the value of present index from the previous iteration. So for the next value, that is, let us say you are going to fill dpj plus 1. While you are entering dpj plus 1, you will want the value of dpj minus j. In case you are updating dpj plus 1, you will need value of dpj. So that is the present value that you have stored in temp. That thing you will be transferring to previous. Why are we doing this transferring to previous? Because you can't directly put it into previous here because you need previous in this step. This step comes after this updation. Because of that, you have to hold it in a temporary variable, then use previous here. Once you are done, at the end of this, you can transfer the particular value to the variable called previous. Once you do this, this whole algorithm will work right. What do you want finally? Finally, you want to return whatever is the value of longest common substring. So return maximum length. Maximum length. This will tell you the length of longest common substring. Let us just look at the algorithm once more. In the algorithm, we first found out the length of x and y. We had a array, a DP array called DP, which is a one-dimensional array of size n plus 1. Keep in mind that this depends on whether x is smaller or y is smaller. Whichever is smaller, accordingly use here. Next thing, you have a variable for max length, which will store the length of longest common substring, and index is a variable which will take care of the index of the last particular position at which common substring is ending. What about the loop? You're looping through each element of x. Then you have a new variable declared, which is called previous. Then you are looping through each element of y. While you are looping, you are preserving or keeping the present value in the dp of j to a variable called temp. In case the values ith element of x and jth element of y match, then you will update dp of j, that is present element, with previous plus 1. After the updation, in case this value is greater than max length, here you are going to update max length and the index, that is longest common substrings length and the index. After that, in case it is not matching, you will do dp of j equal to 0 and previous, whatever is the previous variable, that will now take the value from temp. This is for consistency. So this is the algorithm. If you see this algorithm, space used, the only space used, that is additional space, is for the array, because of which your space complexity is order of n. So ideally I should not write order of n. Instead I should write space complexity is order of minimum of m and n. So whichever is smaller, that will be the space complexity. What about the time complexity? Time complexity will remain the same. It is order of m into m into n. Why is it m into n? It is because you are iterating through each of the character in x and each of the character in y. Because of that, time complexity is order of m into n. But the space complexity is decreased. This is why it is called space optimized dynamic programming for longest common substring. From order of m into n, we brought down space complexity to order of minimum of m and n. This is it about longest common substring algorithm.